Another bodily system which changes over time is the respiratory system. According to Life Science, the human respiratory system is a series of organs responsible for taking in oxygen and expelling carbon dioxide. This enables the body to transfer gases to and from the working muscles to support aerobic glycolysis, as oxygen must be present for the body to utilise the aerobic energy system. The primary organ of the respiratory system is the lungs, which are responsible for both inhalation and exhalation of gases. Up until the age of around 25, the lungs will continue to mature, becoming stronger and more efficient to better support physical activity. However, once passing the age of 35, lung function will remain fairly constant depending upon the subject's lifestyle. However, after the age of 35, lung function will gradually begin to deteriorate. This can be evidenced by lung.org, which says on their website, after about the age of 35, it is normal for your lung function to decline gradually as you age. This can make breathing slightly more difficult as you get older. Lung function begins to deteriorate with age due to a multitude of reasons, beginning with the weakening of the respiratory muscles. As we age, our muscles become weaker and begin to struggle with daily tasks which were previously easy in younger years. This happens to all the muscles within the body in response to age. In response to the respiratory system, the primary muscle is the diaphragm, which is located below the lungs. The function of the diaphragm is to enable the lungs to expand and relax, forcing air in and out of the lungs. Therefore, the weaker the diaphragm will have a massive impact upon the force of contraction and relaxation of the lungs, as it will struggle to create enough force to inhibit a strong contraction, resulting in a reduced lung contraction force, leading less air to be able to filter into the lungs, leading to a reduced tidal volume. Furthermore, as we age, tissue lining the airways of the lungs begin to lose their elasticity. The purpose of this elastic tissue is to enable the airways to stretch to accommodate increased volumes of air to flow through them. However, as elasticity is lost within the tissue, the airways will struggle to stretch to provide space for the large volumes of air to flow through them, leading to a reduction in inhalation volumes as well as tidal volume, as the lungs can no longer hold as much air within themselves, as the airways have become narrower, decreasing the subject's efficiency of breathing. The impact of these factors upon sporting performance is massive. A reduced lung function will lower how much oxygen the subject can provide to their working muscles per breath, as their lungs are less efficient. In response to this, it can be inferred that the elderly will struggle to maintain aerobic respiration during exercise, as they will struggle to continue to provide enough oxygen to the working muscles due to their decreased lung function, which we can infer would lead them to firstly have an increased breathing rate during exercise to try and provide more oxygen to the working muscles. Then secondly, we can infer that the elderly would be forced into anaerobic glycolysis significantly quicker than younger competition, as their bodies would be unable to provide enough oxygen to maintain aerobic glycolysis for long periods of time, forcing their bodies into the less efficient anaerobic glycolysis energy system, which can only be maintained for up to 3 minutes before fatiguing due to lactic acid buildup, which is present in the lack of oxygen. The impacts of this would be particularly negative in endurance exercises, where the aerobic energy system must be maintained for long periods of time. For example, in marathon running, as we could infer that the elderly would fatigue significantly quicker than younger athletes, as their bodies would be placed under increased strain to maintain the more efficient aerobic energy system during the run, which could appear a possible explanation for why, according to podiumrunning.com, fastest runners Fastest runners saw times at 27 years old for men and 29 years old for women. Finally, it is important to note that although all these aging factors cannot be avoided, they can be significantly slowed by living a healthy, active lifestyle to ensure your body remains as strong. Your body and respiratory systems remain as strong as possible for as long as possible.